we talked about, or really, on Monday we talked about side angle side and side side side. Last week we talked about the definition of congruent triangles. Today we are going to learn 3 new congruence theorems. Okay, and they are called ASA, AAS, and HL. Okay, so for your bell work, I told you to draw pictures of side, 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 and side angle side. Okay, your pictures can either have actual lengths in them, or you can use your symbols. So if it's side, 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 Allie, just summarize for me. If it's side, 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 what has to happen? Yep, so all the sides of one triangle are congruent to the 3 sides of the other triangle. Okay, so all sides. Jillian, what happens in side angle side?
There are 2 sides and 1 angle.
Okay, yep, you're going to have 2 sides and 1 angle. Do you remember what had to be special about that 1 angle? Because it can't just be any of these angles, right? Yeah, Nate, which one?
Included angle?
Yeah, good. Okay, so it has to be the 2 sides and the included angle. Okay, and then today we are learning 3 new of them. And these 3 new ones, we are going to have to know what it means if it's an included side. So it's very similar to our included angle. If it's an included side, we can think of it as the common side, which means, right, when you have something in common, you share a same interest. In a triangle, if you have a side in common, you are going to share the side. So the common side of 2 consecutive angles, so remember we talked about last week what consecutive means, right? One right after the other. Okay, so an included side of a polygon is the common side of 2 consecutive angles in a polygon. And obviously the polygon that we're working with today is a triangle. All right, so let's draw a triangle. Okay, and then we're going to call this one PQR. And then we know that angle P and angle Q have these 2 angles, and then we are going to find the included side of those 2 angles. Okay, so we're going to say blank is the included side of angle P and angle Q. Okay, so you're looking for the side that's in between these 2 angles. Izzy, what do you think it is? That. So it won't be an angle, it'll be an included side. So what side is in between your P and your Q? What do you think? The PQ side, right. Good. Okay, so PQ, and this is how you'd mark it. That's once you mark it, you can see it's in between. But if you look at the 2 angles, the side PQ is the only side that has both angle P and Q in it. And then because it's a side, we'll call it your segment. So make sure you have your segment on there. All right, let's try another one. So blank is the included side of angle Q and angle R, and blank is the included side of angle R and angle P. Okay, so Rachel, what is the included side of Q and R? Yeah, you said what? Yeah, segment QR. Yep, good. Okay, so QR. All right, and then Nia, what's the included side of RP?
Segment
RP. Okay, so now you probably see your pattern, right? Yeah, what is it, Nia?
Is this like one of those things where they can go either way?
Yes, 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 yes. So if you put like PR, yep, that would be perfectly fine. What's your pattern here? Like, Nate, how could you explain this to somebody? What do you notice between the angles and then the segment that's in between them?
That they're the same.
What part's the same?
Oh, the angle or the segment part?
When you're naming the segment, what has to be?
Oh, the angle. The first angle has to go first.
Not necessarily has to go first, but you can see that the two angles actually make up the segment, right? So if it's between P and Q, your segment's PQ. If it's between Q and R, your segment's QR. If it's between R and P, it's RP. Okay, so whatever angles it's in between, that's going to make up your segment. Okay? All right, so now that we know that, we can talk about our newest congruence, which is angle side angle congruence. Okay, so this is a postulate. You're just going to use the ASA if you're using it. So it says two angles and the... Do you guys think you know what this fill in the blank is?
Side.
Close. Yeah, included side. Yep. Because see how the S is sandwiched between the two A's? Okay, so that means that it has to be your included side. So two angles and the included side of one triangle are congruent to two angles and the included side of another triangle. Then we know that they're congruent. Okay, so here's a picture that does show you your angle side angle. And so I like to say, oh, it's angle side angle, ASA. Angle side angle, ASA. Make sure that you realize again that your side is the included side. Okay, so your side has to be between the two angles. Okay, that's your included side. Now, we're going to write our congruence statement. Okay, and then I'll give you the first one, your ABC is congruent to triangle, and then I want you to write that. And it'll be by angle side angle. So go ahead and write what it is. Remember that your order matters. Okay, so Julie, what's the first letter going to be?
O-D.
Okay, tell me how you know.
Because it has the same combination.
Okay, and you can see that by the markings, right? D and A are marked the same. Christina, what's going to be the next one? Good, how'd you know that?
Because it had the same marking as
And yeah, in this case, it was none, right? So B and E, they both don't have anything in their angle, so we know it's the same. And then our last one left would be F. Okay, D, E, F. So both of those happen to be alphabetical. That is not always going to be the case. So the order does matter. All right, and then aside from angle side angle, we now have angle angle side. So notice the placement of the S, how it's after the two angles. So this is going to happen when you have two angles and the non-included side. So this is going to be the non-included side. So it's not in between them. And they are congruent to the corresponding angles and non-included side of another triangle. And then we know the triangles are congruent. Okay, so here, this would be angle, angle, side. Okay, you could also have angle, angle, and if this side was marked congruent, that would be okay as well. And then this would be angle, angle, side. Okay, so again, it has to be the non-included side. So we'll start with this triangle, which is triangle GHJ, and finish the congruent statement, and then we would say these are congruent by angle, angle, side. Okay, and Abigail, what'd you get for your congruent triangle? Good, KLM, perfect. All right, any questions for me on that? All right. Now we're gonna go over a couple examples. So this is determine if you can use ASA to prove the triangles are congruent, and then you have to explain. Okay, so determine if you can use your ASA to prove, thanks, that the triangles are congruent. Explain. So if you're determining if you can use this to prove, okay, you're going to have to say yes or no. Whenever it says explain, make sure you guys have something written down in complete sentences. Okay, so you're going to be explaining your thinking there. So looking at your diagram, you're already given this angle and this angle are congruent. This side and this side are congruent. Now think back to our proofs and how I told you that marking up your diagram is going to be really important. Is there anything else that I can mark congruent on this diagram? Yeah, Julie, what?
Like the middle side, like the side that is shared by those two.
Yeah, so if you have a shared side, if that's the exact same side, you know that they are congruent. Okay, because the side is going to be congruent to itself. If we were doing the proof, our reason for that would be what property? Reflexive. Okay, so we're seeing if we could use angle, side, angle. So if we can use angle, side, angle, we need the included side. Ethan, is this the included side or the non-included side? Okay, and how do you know? That, not, what do you mean by You said it's not by the angles? If it is the included side, it has to be, oh yeah, you said the side that the angles are on? Yes, so the two angles are on this side. That's one way to tell that it's the non-included side. I was looking for between, right? If it's not in between those two angles, then we know it's not going to be the included side. So then, can we use ASA to prove it's congruent? No. Can we use something else? Yeah, what is it?
AAS.
Yes, you can use AAS, angle, angle, side. Okay, so now we have to explain, so using a complete sentence. So, no, we cannot prove, I guess that kind of looks like an E, but it is a C. Okay, so no, we cannot prove the triangles congruent by angle, side, angle because there is no way to know if the included sides are congruent. Okay, so that would be a complete sentence. You're starting off with a yes or a no. Okay, we cannot prove the triangles are congruent by angle, side, angle because there's no way to know if the included sides are congruent. Because you do have the two angles. So you're just stating specifically what part is missing in order to prove it. All right, and then let's make a little note. You wouldn't have to write this in your explanation, but it is good to understand that you could prove them congruent. You could prove the triangle's congruent by angle, angle, side. Whoa, too many angles. By angle, angle, side, using the reflexive property. To show the non-included side are congruent. Okay, so this one can be your example if you were going to say yes. So yeah, you could prove the triangles are congruent by angle, angle, side. You would have to use the reflexive property to show that the non-included sides are congruent. And then you'd have your angle, angle, side. All right, and then our next example says use angle, angle, side to prove the triangles are congruent. And then I'm actually going to give you the given. Okay, so this is just telling you what you're going to use to prove the triangles are congruent. And then you are going to be given two statements. The first one is that JL bisects angle KLM.
You can't see the side.
Oh, thanks. And the other statement is angle K is congruent to angle M. Okay, and then we're going to set up our proof. Okay, so you guys are going to start doing proofs without any help. Okay, so we're going to set up our statements and our reasons. That was a big sigh that you let out. Okay, for this one, I am going to tell you that there are 5 steps. Okay, and then you are going to use your given in 2 different steps. Okay, and you don't necessarily have to write something down right now, but if you and your elbow partner decide that you're confident in what you want to start with, you can. But I want you to just talk to your elbow partner about which given statement you should start with and why, because you have 2 given statements. Okay, so just talk to your elbow partner about which one you're going to start with and why. And if you can start with that and do the next one, then I want you to do it.
Honestly, I don't know. I feel like there's no sisters.
I'm pretty confident that I just don't know why, but I just like that that's how it works.
Try flip around. That's not very nice.
some of us fared with this. So there was kind of a mix of different ones. There were a couple people who wrote down the correct first step and the correct second step. Griffin, can you just tell me what you started with and how that led you into your next step?
Segment JL bisects angle KL.
Okay, so we'll start with that, and then how did that lead you to your next step?
The next step would be definition of angle bisector, which is maybe a side-to-side angle.
All right,
Or
so
angle side.
if you have that JL bisects KLM as your given, that statement is going to automatically lead you to your next step. Because if you know that you have a bisector, what pretty much always happens after you say that something bisects? You're going to use that definition, okay? So I know a lot of you put them like one right after the other. If you did that, then it really wouldn't matter which one you started with. But if you start with your bisector, then you can use your definition of an angle bisector. Now, if you did put them both in the same step, that would be fine. Okay, so that's not something I'd mark wrong. If you started with angle K is congruent to angle M, I wouldn't mark that wrong either. Okay, and if you did them one right after the other, that would be fine. I just want you guys to see that, oh, if I start with this, it's automatically going to lead me to my next step, and this step should follow this statement. Now, when you're deciding what goes here for the statement, you have to actually look at the picture. So some people have trouble writing this statement, and I think it's just because you aren't really looking at what's happening. So if JL is going to bisect angle KLM, I might even just say, oh, here's KLM, and then based on the definition of a bisector, Josie, what do we know is congruent? Good, so angle KLJ, and you said that was congruent to MLJ. Perfect. So based on the fact that this cuts the angle in half, I would say KLJ is congruent to MLK. And it should be in that order. And then look, I also marked it off on my diagram. Okay, so now what I'm going to do is use my other given. Okay, so my other given statement is that angle K is congruent to angle M, and that's actually already marked off in my diagram. And again, wouldn't matter if you started with that first, that would be perfectly fine. It's just these two should follow each other. All right, so now I have an angle and an angle. If I'm using angle, angle, side, I want it to be one of the non-included sides. There are two of them, right? It could be KJ and MJ, or it could be LJ and itself. So, Rachel, what one are we going to use? Based on the reasoning of what we did up here. What do we do up here? What do we pick out? Okay, yep, so then what's our shared side for these two? Yep, so then I would say, how would I write that as a statement? Nope, so before we can say that the triangles are congruent, we just have to state that this side is congruent to itself. So how would I say that? Yeah, yep, I would just say JL is congruent to JL. All right, and then Ella, what property would that be? Reflexive. So this would be the reflexive property. Okay, and then your last step is what you have to prove. Now, this didn't say what to prove explicitly. It just said use this to prove that the triangles are congruent. So your two triangles, the way that you write them is going to be important. So if I wrote triangle JKL, just because that's alphabetical, it's okay if you wrote it a different way, then I would have to look here and see what the congruent triangle would be. Ziggy, what triangle is congruent to JKL?
JML.
Good. Okay, so you'd have JML. And then we used angle, angle, side. We talked about this step last week. Whenever you have two congruent triangles, your only options for your reasons, as of last week, were side, 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 angle, side, and then definition of congruent triangles. Now we also have angle, angle, side, and angle, side, angle. But you should not have anything other than those. All right, now we're going to learn about the last one, which is HL, which we don't have any S's or A's anymore, right? We have HL. This one is a little bit different, and that's because it can only be used with one type of triangle. Okay, so the HL congruence stands for the hypotenuse leg congruence, and you can only use this if you have a right triangle. Okay, if you have a right triangle. So if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then we know the triangles are congruent. So let's just recap real quick the parts of a right triangle, okay? So we'll draw a right triangle over here. I'll use my little thingamabob. Okay, so for a right triangle, how many legs do you have in the right triangle? 2, the same as us. How many hypotenuses do you have? 1, the same as us. Just kidding. We don't have hypotenuses. Okay, so hypotenuse is always across from the right angle. Okay, that's why it's special. So the hypotenuse you can always find because it's the side across from the right angle. Did you guys already know that? That's going to come in handy later on in the year as well. Okay, so our two legs are the two sides that are related how to the right angle? How could we describe that?
Next to?
Yeah, they are. They're next to it, and they form it, right? So if it's a leg, it's going to be touching the right angle, okay? It's going to form that right angle. Okay, so basically, you just have to ask yourself a few things if you can use the HL congruence triangle. Now, what I would do is I would pick out these parts. I just label them with an H. If this is a right angle, do we know what this angle has to be? Yes, because these two together form what? A linear pair. Good. Okay, so those have to be a linear pair, which means they're both right. So now I can pick out the hypotenuse. So across from the right angle, across from the right angle. I'll just label that HYP for hypotenuse. Okay, now another thing you want to pick out on your diagram, well actually we'll do the checklist first. So your checklist is, do you have right triangles? Are both of these right triangles? Yes, we just showed that they were because they each have a right angle. The next thing is, are their hypotenuses congruent? So congruent hypotenuses. Are these two congruent to each other? Yes, you can see by the markings, right? Okay, so we have 2 out of 3 right now. The last thing that we have to show is that you only need one pair of congruent legs. Okay, so if we look at these 2 legs, there's nothing that shows they're congruent. If we look at these 2 legs, can we show those are congruent? Yeah, how? They're the same, right? If they're the same, then I can show they're congruent by what property? Reflexive. Okay, so the leg is the same for both triangles. So they are congruent by the reflexive property. Can you guys see that we've already used that several times today? In the last 3 examples alone. Okay, so do we have one pair of congruent legs? Yeah, this is our one pair of congruent legs. Okay, so if it meets all 3 of those conditions, then we would say, yes, they are congruent. And we're going to name the triangles. Oh, well, we're not going to for this. Sorry, they didn't give you names. Okay, so yes, the triangles are congruent by the HL theorem. Okay, and it just says to determine if you can use them. So yes, the triangles are congruent by HL. Okay, now for this, let's pick out what 2 triangles we're talking about here. So we have 2 triangles in the diagram, right? We're talking about this and we're talking about this. All right, so let's go through our checklist. Do we have right triangles? Yep, okay, so far so good. Do we have congruent hypotenuses? Right, this is the hypotenuse, right? This is the hypotenuse, okay, maybe. Do we have congruent legs? Again, one pair. Yes. Okay, so these are your legs, right? One pair of congruent legs. Is there any way to show based on this information that the hypotenuses are congruent? No. Okay, so there's no way to show that they are. So for this I put don't know, can't tell. Okay, so no, we can't prove the triangle's congruent. By HL, since there is no way to tell if the hypotenuses are congruent. Okay, so we would need either a symbol that shows they're congruent or a number that shows that the lengths are the same. All right, and then your homework for this section, 4-5, is on page 256. And then I'm going to go over questions from your homework last night, but if you don't have any, you can go ahead and start your homework.